Hi everyone, welcome back. So this week you've been solving practical problems that involve multiplying a whole number and a fraction. Well, today we're going to continue with just that. We're going to learn a new method today. Let's take a look at our learning target. All right, our learning target reads, I can solve single-step problems involving multiplication of a whole number and a proper fraction using repeated addition and tape diagrams. So we're going to practice with some repeated addition today and see how that connects to multiplication. And again, we're going to practice with tape diagrams to help us make sense of word problems. All right, problem one. Alex's water bottle holds 2/5 of a liter of water. If he fills the bottle completely 10 times and drinks all the water, how much water does he drink in all? So I'm going to start off with this problem by having a tape diagram, which I've split up into 10 sections. I know that each one of those sections represents 2/5. Now, if I want to figure out how much water Alex drank in all, I can use repeated addition and add those 2/5 together to get my answer. So I need to add 2/5 together 10 times. And here you'll see that I've modeled 2/5 and I have that 10 times because that's how many times we need to add 2/5 together. So if I start with the first one, I have 2/5. If I add 2 more fifths, I have 4/5, then 6/5, 8/5, count with me, 10/5, 12/5, 14/5, 16/5, 18/5, and finally 20/5. So I know that 20/5 is my answer, and I know that this improper fraction of 20/5 can also be represented as a division problem. I know that 20/5 means the same thing as 20 divided by 5. And I know that 20 divided by 5 is 4 because I know that 4 times 5 is 20. You can work division problems backwards because we know that the opposite of division is multiplication. So I have 4. So let's see if we can see that with our models too. What if I put all of these 2/5 together? And now I see that I have 1, 2, 3, 4. So I know that my answer to this problem is 4. And if I put that in a sentence, I could say that Alex drinks 4 liters of water in all. Okay, so we solved this problem using repeated addition. Let's say that instead of adding 2/5 together 10 times, we took 2/5 and we multiplied 2/5 times 10. Here you'll see that my denominator is still the same, but I know that 2 times 10 is 20. And that's that same 20/5, which we know is equal to 4. So that's problem number 1. Let's look at problem 2 now. Problem 2 reads, Robert used 2/3 yards of string for each bracelet he made. He made 12 bracelets. How many yards of string did he use in all? All right, now for this problem, again, I'm going to have a tape diagram. This time, how many sections do you think I'm going to divide it up into? If you said 12, you're right. I need my tape diagram divided up into 12 sections. Each one of those 12 sections is going to represent 2/3. And if I want to know how much string Robert used altogether, I know that I can add those 2/3 together to get my answer. So if I start with the first one, I know that 2/3 plus 2/3 is 4/3. Then I would have 6/3, 8/3, count with me, 10/3, 12/3, 14/3, 16/3, 18/3, 20/3, 22/3, and 24/3. So I have my answer of 24/3. Now this can also represent a division statement. And I know that 24/3 means the same thing as 24 divided by 3, which is 8, because I know that 8 times 3 is 24. All right, and in my final answer in a sentence, I could say that Robert used 8 yards of string in all. Let's take a look now at problem 3. It reads, Eamon read 1/8 of a book each day for 24 days. How many books did he read in all? All right, so starting out for this problem, I know that if I have my tape diagram, I need to divide this tape diagram up into 24 sections. Each one of those 24 sections is going to represent 1/8. And I could still use repeated addition for this problem, but I would just need to add 1/8 plus 1/8 plus 1/8 plus 1/8 24 times. So instead of doing that, I could say 1/8 times 24. I know that my denominator of 8 is going to stay the same in this case, and I know that 1 times 24 is 24. So I have 24/8, which means the same thing as 24 divided by 8. And I know that 24 divided by 8 is 3, because I know that 3 times 8 will give me 24. So my final answer in a sentence, I could say that Eamon read 3 books in all. All right, looking now at problem 4. Here we have our problem, which says to prepare a fruit salad, a chef uses 3/4 of a cup of strawberries per serving. If she has to prepare 12 servings, which option can be used to find how many strawberries she needs? And you'll see here that we have 4 different answer choices for this problem. Okay, so I'm going to start off solving this problem the same way that we solved the other problems. So I know that a chef uses 3/4 of a cup per serving, and she has 12 servings. So I know that I could either add 3/4 plus 3/4 plus 3/4 12 times, or I could say 3/4 times 12. And in doing so, my denominator would stay the same, but I'm going to say 3 times 12 is 36. I know that 36/4 can be written as a division statement. So 36/4 means the same thing as 36 divided by 4, which is 9. So I know my answer is 9. But when looking at these answer choices, A, B, C, and D, I don't see 9 as an answer. So which one of these answer choices is going to be equivalent or the same as 9? And that's what we need to figure out now. So looking at my different choices here, I know that when I first started this problem, I multiplied 3/4 times 12. So I'm going to look at my answer choices and see. A, I have 12 times 3/4. B, 12 times 3/4. C, 12 times 3/4. D, 12 times 3/4. So the first part of all these answer choices looks good. Let's see what I did next. Next, I did 3 times 12. So I need to look at my answer choices and see, do I see 3 times 12 as a next step in these problems? Well, when I look at A, I see that they have 12 times 3/4, which is what I did, but then they have 12 times 2. And I didn't multiply 12 times 2, I multiplied 12 times 3. So I'm going to eliminate A. B, I do see 12 times 3, so I'm going to leave B for now. C, I see 12 times 3/4, that checks out, but then I see 12 times 4. I didn't multiply 12 times 4 to solve this problem, so I'm going to go ahead and eliminate C. And then looking at D, I have 12 times 3/4, which checks out, and then I have 12 times 3, so I'm going to leave D for now as well. So after I did 3 times 12, or 12 times 3, what did I do next? Well, I know that 12 times 3 is the same thing as 36. And now let's try. If I did 36 times 1/4, which is the same thing as B, I know that my denominator would stay the same, and 36 times 1 is 36/4. Now 36/4 is the same thing that I had when I first started this problem, and that 36/4 gave me my answer of 9. So I know that B would be my answer for this problem. We made it to our practice set for today, which means it's time for you to show what you know, show what you've learned today and this week, and let's practice 4 problems on your own. You ready? All right, here we go. Here are your 4 problems to practice with today. The first problem reads, Jane, Jacob, and Josh each drank 2/3 cup of milk at dinner. How many cups of milk did they drink in all? Next, Maria needs 3/4 of a foot of string to make each bracelet. How many feet of string does she need to make 4 bracelets? Next, Kyla runs 5/6 of a mile each day. How many miles does she run in 24 days? And finally, a gardener has 10 pounds of soil. He used 3/5 of the soil for his garden. How many pounds of soil did he use in the garden? Pause the video here and solve these 4 problems on your own. Press play when you are ready to check your answers. All right, let's go ahead and check your answers so you can see how you did today. Problem number 1, your answer is 2. One possible sentence, Jane, Jacob, and Josh drank 2 cups of milk in all. Problem number 2, your answer is 3. And one possible sentence, Maria needs 3 feet of string to make 4 bracelets. Problem number 3, your answer is 20. And one possible sentence, Kyla ran 20 miles in 24 days. Problem 4, your answer was 6, and one possible sentence. The gardener used 6 pounds of soil in his garden. That's all I have for today, 5th graders. Thanks again for another great day, and I hope to see you back tomorrow for another math lesson. Bye, everybody.